Power supply elements. There are three types of power supplies. Independent, dependent, and time-dependent. Supplies. Power supplies can be either active or passive. If they are active, then they deliver power into the circuit. So let's start off with the first one, which is independent power supplies. Caution. We have a language problem. Language is tricky because physics 4B usually does not distinguish between voltage sources versus power supplies. Voltage sources have no load in the circuit, while power supplies have a load that has both current and voltage. So a voltage source is an ideal voltage source that only puts out a voltage but no current. Power supplies must deliver both voltage and current. There are two types of independent power supplies. Okay, here's the first one. We call this a voltage source. So what is a voltage source? It's a power supply with a constant voltage, but variable current. That is what we mean by a voltage source. So if I look at a voltage source, then we have something like this. So if I color this guy, we could then say that if this is positive and negative terminals, and this is my voltage source, then if I have a current entering here, so if the source current enters the negative terminal, then we say this is an active voltage source. On the other hand, if I have this scenario where the current enters the positive terminal, then we say that this is a passive voltage source. So let's think of a simple example to give you an idea of what we mean by this. A 9-volt battery, and a lot of times people call it a voltage source. And I'm going to say that that's actually wrong. I would come back and say you cannot call this a voltage source. And the reason why you can't call it a voltage source is that the battery puts out voltage and current. But for shorthand, we'll typically say voltage source. But technically, it's not a voltage source. It's a power supply. So a non-volt battery is an independent power supply. This implies the 9-volt battery remains fixed at 9 volts re regardless of the variable resistive load. So picture-wise, I imagine that I have my source, and then I have my resistor here. And what we're going to say here is that if I have a 9-volt battery, that means that 9-volt battery is fixed. So now let's say that this is my load resistor, and let's give this a range of 1 kilo ohm to 5 kilo ohms. So what you're seeing here is that this guy right here is a variable resistance. So that means here is that if I look at the current coming here, that current of the resistor, which is also that of the source, is going to change. So if the R load is equal to 1 kilo ohm, then that tells me that the source current is then going to be 9 volts divided by 1K, which will give me 9 milliamps, while the voltage of the source stays at a constant 9 volts. So if I look at this thing, this tells me here that the voltage is going to stay 9 volts while the current is 9 amps in this situation. Now, what happens if something's different? If we now change the load resistance to 5 kilo ohms, now the source current then becomes 9 divided by 5K, which gives you 1.8 milliamps, while the voltage source stays at 9 volts. In other words, the voltage source keeps the constant voltage, but there's a variable current supply. In other words, a voltage source is a constant voltage, but variable current power supply. So physically, we could then say the power supply will adjust its power output by keeping voltage constant at the cost of changing the current output. Now let's go to the other power supply. The other power supply that we have, the second one, is a current source, which is not talked about in physics 4b. So this guy, it's a power supply that's of course opposite to a voltage supply with a constant current but variable voltage. So picture-wise, what do we see here? I think I might have this guy here. So let me adjust this image so that we can move a little bit quicker here. So here we go. Let's say that this is my current. So if I look at this current here, that means that this current here has a current that's moving up. Now we have to pay attention to the voltage. So if the voltage across the source has the current going entering the negative terminal, then this here is an active current source. On the other hand, if the voltage switches, in other words, that the voltage here, that this is positive and this is negative, then the current enters the positive terminal. This will then be passive. So to get a sense of what a current supply does here, let's look at this. So an example similar to the 9-volt, imagine that we have a 5 amp current supply is a independent current source where the current output is constant at 5 amps regardless of the variable resistive load. So picture-wise, I imagine that I have a source. So here's our source. And it's going to be supplying 5 amps, and this will be our load resistor. And as before, we picked a range of 1 to 5 kilo ohms. Once again, we'll say that this guy right here is a variable resistor, like a decade resistor box. So what we know here for a fact is that this current here, without any doubt, must be 5 amps. These two elements are in series. But there's a cost. And the reason why there's a cost here is that this guy has to be a variable voltage source. As an example, we could think of this following situation. For our load equal to 1 kilo ohm, I have the same circuit here. So let's copy this and just bring it down here. And this is what I'm seeing here. So if this load is 1 kilo ohm, then the voltage across this guy must be the same as the voltage across the resistor. So what this tells us here is that the voltage of the source must be the voltage of the resistor, which will then be R load times the source current. So in this case, it's going to be 1 kilo ohm times 5 amps, which then gives us 5,000 volts for the source of the voltage. While the source current remains at 5. So in other words, we have a fixed current of 5 amps, and we see here that the voltage is now 5 kilo or 5,000 volts. Let's repeat the same process now for load, which is 5 kilo ohms. So if I do that, let me adjust this circuit again. The load here is now 5 kilo ohms. So what is this source voltage? So very similar to what we said before, the source voltage must be the same as the resistor voltage. There's only two elements. So when I put this in, you could see that this will be 5 kilo ohms times 5 amps, and the voltage has now bumped up to 25,000 volts. While I source stays at 5 amps. Variable voltage, constant current. So now we could say the exact same thing as we did before. A current supply is a constant current, but variable voltage source. physically, the power supply will adjust its power output by keeping constant current at the cost of changing the voltage output.